So welcome to the line following crash course video for the Elegoo robot. What we're going to be covering in this video is how to use this 3 light sensor mechanism or board to follow a line. So it's essentially a black line on a white background. So this board has a few parts. The LEDs tell you if the sensor is detecting a light actually if it's not detecting a light reflection. So you'll see that it is on, whereas if I put something close by, that turns the light off. Okay, so that means it is actually seeing a reflection off the pencil, and so it turns off, and it can keep going to different ones. Okay, so the circuit has a transmitter and a receiver, and then that status light. So, and then there are 3 of them: the middle, left, and the right. It also has a sensitivity adjustment knob over here. So this is a potentiometer, and you can use a screwdriver, a Phillips screwdriver or a flat screwdriver to turn it either clockwise or counterclockwise to adjust how sensitive these are. So at which point they say that this is enough light for me to register a 1 or that I've detected this. So if you have different lighting conditions, you may need to adjust this knob. That has to just be a trial and error, and you can use these red lights to see how it works. So you could put the sensor over top of a black line with a white background next to it and turn this knob until only the black line light turns off and not the other one. So it's a bit of trial and error. Also on this webcam, you can actually see these lights. You can see these kind of bluish purplish lights. To the naked eye, they don't show up at all. So this is infrared light that camera sensors can't properly filter out. So it gives you, on one hand, it gives you a nice idea of what it is. On the other hand, it's not actually what you will see. You will see these red lights. You should not see these blue-purple lights. Okay. So the basic theory of operation on here is that this sensor should not see a reflection because it should be over top of the black line, and then these 2 sensors should see a reflection because they will be over white. So the whole purpose of the line follower is to keep this guy over top of the black and these guys off of it. So if the robot starts veering to the left, this sensor all of a sudden will be over top of the black line. So the right sensor will be on top of the black line, and so you'll want to steer your robot to the right to compensate for the veering to the left. Okay, and then vice versa. If your robot's starting to drift to the left, you're going to have the right sensor start picking up some black line, and you'll want to turn to the right to get that sensor back onto the white. Okay, so that's what we're going to be doing. But the first step before we start actually doing the line following is to make sure that the code is reading those sensors, those light sensors, and they are just on off. So when they hit a certain threshold, they trigger. So let's look at some code. Let's start by creating a new project. And so this one will just be, what else I'll call it, line follower. We'll start with just a light sensor test. So into the code, remove the defaults. All right, so the first thing we need to do is define where these sensors are. So let's define light sensor left's pin. So this is normally 2. So if you have the default Elegoo setup with out of the box kind of thing, it'll be 2. I've actually moved those pins on my robot, so I'm just gonna define it as A0 and make a note that it is normally 2, and that's probably what you will have on your robot. I just needed those pins for something else. And for me, this is A1. It is usually pin 4. And this is another reason why having defines for your pins is so useful, because mine is A012. But you could easily copy this code and then just change those numbers without having to change anything else in the code. All right, so we have our pins defined wherever they should be. Let's look at setting them up. As usual, we start with opening the serial port. Come on. 115.2. And a line follower v1 test. All right, so then we're going to send our pins. All three of them are inputs because you're just looking to see if they are a 0 or 1. So left is an input. Middle is an input. And right is an input. All right, so for now, let's just see the value of those sensors. So we're just going to do a serial.print line on the digital value of these. So digital read, light sensor left. Don't mess up the bracketing. Like that. And then I don't want to overwhelm my serial port, so I'm going to put in a delay so we get 5 of these a second. All right, so let's select my TCP wireless. And let's try and program it. Good. All right, so now if we look at our monitor, we're getting 0. And then I'm only getting 1, 0. Is this actually, is there clear on here? Clear. Yes, we are getting that. Oh, I did a print line on each one. This is a lot prettier if you don't do a print line on each one, you put them side by side. Try that. Right, and it doesn't want to do that. All right, I'll just have to reset things. Hold on. All right, that for some reason took a few power cycles and resets and reloads, but finally programmed again. So now if we go back and we look at the monitor, so you can see that all 3 sensors are reading 0, which is what the red light means. And then if I take this white eraser and I brush over, we should see some 1s coming on. If I'm not too far, there you go. 1, 1, 1. If I go at it this way, I might get all 3. There you go. Okay. So that means the sensors are working the way we expect them. And we could also take this robot and put it on the mat over a black line and kind of move it from left to right over the black line and make sure that the gain or the sensitivity is properly set on this knob. And if it isn't, kind of turn it, maybe 5, 10 degrees, and then try it again, and then turn it and so on. So mine's actually set maybe 20 degrees clockwise from the default. So, all right, so the next step, assuming this works well, is to actually code the line following part. So this is adding the logic that will say if the right sensor is over top of black, we need to turn right, and if the left sensor is over top of left, we need to turn left. Now, when we get in order to do this part, the line following part, we need the motors to run. So I'm going to add a file, and so I'm going to call it drive.h. Drive and make it a .h. Probably be more proper to create an H file and then implement things in the C file or C++ file. But this is just an example. So we're going to copy the Elegoo drivetrain information over. So here, hopefully you already have this for your robot if it's already running. You have the 6 pins that are needed to control the the board that drives the motors. Again, there's one pin that I moved, so EN3 is usually pin 9, but I've moved it to pin 12 because I need pin 9 for something else. So that's something you'll have to watch on yours. Car speed is how much power out of 255, 0 to 255 that I'm applying. I found that line following works pretty decently at half power, which is about 128. The drive setup just sets the pin mode for all of these as outputs. Drive forward sets the car speed and the control lines so that the car is going forward. I'm not actually using drive back, but it's in here for completeness. Drive left just changes these control lines to make it turn left. Same for right, and stop just turns off the main enable lines. Okay, so this is all part of the Elegoo stuff. In fact, maybe a good side note here, this whole example of line follower can be found on Elegoo's official site. So if you do Google the Elegoo Smart Robot Car Kit v3.0, you should come to here. And if you scroll quite a ways down right here, and you go to resources, and go to the tutorial and code, you can download a zip file that is the v3.0 plus. And in that zip file, there are examples under the English folder. And this is, I think, lesson number 5 or something that tells you how to do line following. And this example closely follows what they have. They even have a little bit more of the theory and diagrams and documentation and stuff. So this is just the crash course version, but you can go into Elegoo and learn about essentially line following, obstacle avoidance, moving the car, and so on. So that's why I'm not going to spend too much time on the actual moving of the car because that's covered elsewhere and also in other workshops from WWFIRST. All right, so going back to the main file over here, we now need to include drive.h because that's where all the code is for our motor stuff. Okay, and then also in the setup, we need to call that drive setup function so that the pins are set as outputs. All right, so this is no longer necessary because we're no longer printing that. We're wanting to implement the line following. Okay, and at its simplest, it is pretty simple. You're going to read the middle pin. So we're going to do digital read on the light sensor middle. Now, if that's equal to 0, that means it's not seeing a reflection. That means it is seeing a black line. So if that's the case, we just want to drive forward because the middle sensor is on the line and we're happy with that. If the middle sensor is not on the line, let's see which side we veered off on. So let's look at the left. Okay, and if the left sensor is over top of the black line, it means we've drifted to the right. Okay, so your left sensor is over the black line, it means you've drifted to the right. So you need to drive to the left to get the black line from under the left sensor to the middle sensor. Because that's what ultimately we want, leave it on the middle sensor. If the left sensor is seeing white, then let's check if the right sensor is seeing the black line. If seeing nothing. Okay, so if the right sensor is seeing the black line, that means we veered to the left and we need to drive to the right to get back on track. Now this is the complicated case. What if we've lost the middle one, but we've also lost the right and the left, so we're not seeing black line anywhere? Well, in that case, all we can do is stop because we don't have enough information to recover. We could instead try going backwards because maybe we overshot something. So if this loop doesn't run fast enough, you may miss that transition where, let's say, the left sensor goes over the black line because you're veering right. Eventually, you'll veer right so far that the left sensor won't see the black line either. It'll just see white. So that's the case where maybe backing up would be the way to go. Or if you're, when you're coding this, if you're thinking, well, the left sensor was seeing it, and now it's not anymore, so I should have been driving left. Well, maybe I need to drive left more aggressively. Maybe I really have to put this into a spin. So if you kind of keep some history around, or if you know what you're doing, or if you have some knowledge of what your lines will look like. If you know there's a hard right turn after a certain amount of distance or time, well, maybe you can start pivoting your robot separately and then let the go forward until you reacquire the black line. So there's a lot of logic that you can put into here, but for now we're going to keep it simple and just do it like this. And in fact, this is almost enough to do your auto for this year's game. The very first corner that's outside of the starting box is a little hard uh, to catch with this code. It probably won't catch it, but most of the rest is quite doable. So let's give this a try by programming it. See if we made any silly mistakes. There you go. Well, the fact that my robot's now moving means something. You can kind of see through it's actually those wheels are turning right now, so it's a little confused. Oh, it's because it's sitting on the desk and jamming the wheels. All right. So now it's essentially looking for, so let's go over to the mat over here and see. I'm actually going to turn it off a second. Hold on. There you go. So I'm going to take my, maybe it's reach. A little bit too wired with all my equipment here. So we're going to start it off in the starting block, like that. And I'm going to turn the switch on, and it will probably stall at that first corner past the A. So, or go straight through. Hold on. All right, so what happened there is that I had tuned my sensitivity for upstairs in the daylight, and downstairs has just pot lamps, so it's a lot darker. So I think I have to go back and adjust my sensitivity. So I'll go do that and be right back. All right, so I checked my sensitivity and it was actually responding properly to the black line. So I checked my code again and it's a bracketing problem. So that goes like that. Bonus points to anybody who figured it out first. So what we want to say is to digital read the proper pin, and if that is equal to 0, then drive forward. The way I had it is some interesting C'ism. This would have returned, is that light sensor equal to 0? The answer would have been no, so it would have always been reading the pin 0 instead of the pin it wants. So this is not even close to what we want. What we really want is to read that pin, not to have some weird comparison operator inside to specify the pin we want to read. That's the pin we want to read. That's what we want to compare it to for all of them. So now let's try building that and seeing if it will work. And just to make sure, let's reload this page. Reselect the port. So now if the robot's sitting on top of white, it should actually not move because the logic is saying if it's on top of white, don't move, only move forward if you're on top of black. So if the robot takes off or if it doesn't sync. All right, hold on, I'm just gonna reset him, be right back. All right, so power cycling and reprogramming seems to have worked. So now I'm gonna take the microphone off and I'm going to put the robot on the starting line and it should start to follow the line, probably stop at A. I'll to turn it slightly and then it should follow the rest of it. So let's go see if that works and we might as well go to full camera. All right, so it did follow along. That first corner was a little sharp for that, so we'd have to put in some extra logic to kind of make it keep turning or turn more aggressively or change the speed of the robot to get around there. But for such a simple piece of code to just say, if we're on the black line, stay on it, and if we've drifted to a side, kind of turn to the other side, that's pretty effective. So yeah, if you want to get extra performance, extra speed, you'll definitely need tweaking. You'll need to watch things like having the mat on carpet might make the mat not lay quite as flat. So then your line's going to be physically closer to the sensors in some place if there are bunkles. So that's something to watch out for. But other than that, doing this should work pretty well for you. So hope that's been useful.